Welcome back. We have seen as a consequence of the second law that if we have two reservoirs at say T1 and T2, and now let us be clear, this is T1 greater than T2, then we can run an engine like this, absorbing Q1 from the high temperature system T1, rejecting Q2 to the low temperature system T2, and the engine produces work which is equal to Q1 minus Q2. We also know that it is possible, if we provide a direct contact, to have a flow of heat from the high temperature system to the low temperature system, but it is not possible to have a heat flow from the higher temperature system to the lower temperature system. However, through the same conductor or a similar conductor, if we want heat transfer from the low temperature system to the high temperature system, this is not possible, and this actually is the Clausius statement. So, which we have now derived as a consequence of our study of the second law of thermodynamics. But remember that quite often we need to do this. We need to transfer Q2 out of the system at T2. Then it turns out that if we want to do that, a direct transfer like this is not possible, but we can have a cyclic device which will absorb the required amount of heat Q2 from the low temperature reservoir or low temperature system at T2. This device will absorb some work, unlike an engine which delivers some work. So, look at the sign of work. For the engine, the sign of work is outwards, the engine produces work. Here this system absorbs work. It is a cyclic system and it provides or rejects heat Q1 to the high temperature reservoir at T1. Notice that the scheme in directions is exactly opposite that of an engine. This cyclic device is usually known as a refrigerator, and the Clausius statement of the second law of thermodynamics says that W must be greater than 0. That means refrigerator requires some work to be consumed, just the way engine requires some heat energy to be rejected. Thank you.